So, again, our agenda, we'll talk about Tecplot 360EX, what's new, and we'll focus on the top 5 reasons you should be interested in the technology. So let's talk quickly about what is Tecplot 360EX. And Tecplot 360EX is our most significant upgrade to the Tecplot family. We've been working on this for about 24 months. Is that about right?
That's about right, yes. It's been a long haul.
Yeah, and it's important to understand kind of what we've done. This is not just a simple makeover. I know a number of people out there have gone through simple makeovers where they just update the UI technology. But we've actually went to technology which has a new UI, as well as we've kind of decoupled some of the inherent technologies, and it's much more modular in the way that it's built, which will be great as we start adding in additional functionality. The other thing we focused on is speed. And speed's really important because at the end of the day, people need to get to an answer as quickly as possible. Our goal is to give people tools to get to an answer 100 times faster than they did before, and that's important.
That's right. And not only that, but do it with less memory so that you can run it on your local workstation or your laptop, even for the large cases.
Absolutely. And we're going to go through a couple of large cases on my laptop here this morning. There's also been a renewed focus on ease of use, and our goal all along, Tecplot's always been a relatively easy-to-use tool. I mean, it's of the major post-processors on the market, Tecplot is by far the easiest to use. But we said that's not enough. We really need to make it so that my 12-year-old middle schooler could get in there and at least get to a picture, maybe not an answer, as quickly as possible. And finally, one of the things people have been talking to us about for as long as I've been at Tecplot is, when are you going to have a native interface on Mac? And so we are now working with the technology that gives us a native Mac interface. So pretty cool stuff. So let's go quickly, and we're going to start with some of the new technology around subzone load on demand.
Okay, the big thing here is the speed. And the way we do that, well, the speed and memory. So it's 10 to 100 times faster, depending on how large the data set is. Well, if it's a small data set, it may only be a factor of 2 faster. But if it's a large one, hundreds of millions of cells, it may be a factor of 30, 40, and then you get up into the billions, you're looking at hundreds of times faster. And it uses significantly less memory. So the 90% is for a case that's about 200 million cells. It's 90% less memory. And as a bonus, it does use a new file format. But the bonus is that the file format is actually significantly smaller. So 40% smaller. It's almost a factor of 2 compression. So it's a big improvement. And the way it works is to really focus on only loading and calculating the data you need for the particular plot you're doing. So if you're doing an isosurface, it breaks up the data into pieces, and it only loads those pieces that it needs to generate that isosurface. And it uses an indexing scheme based on an interval tree. And when you're calculating a variable, it uses interval arithmetic to estimate the ranges of the variable and those for the new variable. And so even when calculating a new variable, it doesn't have to load significant amount of data.
And where we've seen this is really significant is if you have a lot of data files. So we have folks who routinely look at maybe 10 to 100 solutions for a given project. If you can reduce the processing time per solution by an order of magnitude, you really can speed up the analysis. And this translates, of course, into Tecplot Chorus and other things that we're doing. So we'll talk about that. How it works is pretty simple, Scott. I don't know if
this is just a really simple example of drawing a contour line, that blue line. And the way it works is you break the domain up into subzones. This is a simple example of rectangular or square subzones. And then you see on the right, it doesn't load the gray subzones. It only loads those subzones that the contour line goes through. Or more specifically, it only loads those subzones that have the contour value in the range for that variable, for that subzone. So it's a simple concept. It did require a major rework of the internal data structures in Tecplot 360. So it has been a significant change to the code, but it gives dramatic improvement in performance.
And we'll actually go through a couple of examples, and it is really amazing. I'll be honest with you. In fact, as we'll see, you can load, a 200 million cell model in 4 seconds.
Yeah.
I mean, that's insane. It's which is great, and so we'll talk about that a bit here. Other things that we've been focusing on have been around improvements in the way that you work, and there's overall we've had a design strategy which was keep it familiar, but not identical, but keep it familiar because people have been using Tecplot for a long time. But focus on things that people have wanted to do and decrease the number of clicks necessary to get it done. And we'll go through a couple examples, and I'll show you that everything from changing curve style to improvements in the way that both our zone styles dialog works and the way that we do contouring is just way easier. And we'll talk about that. I should also point out that what I'm going to show you here today is where we are today, meaning that there's still some work going on, and I'll even put the caveat, since I'm sure some of the developers here would love to make sure that I say this. This is a work in progress, and there's always the possibility, because I'll be doing this live, that it doesn't behave, but I'm assuming it will.
On the wire without a net.
That's pretty much it. So, other things that we've focused on have been slicing. A couple of things that people have been asking as long as I've been here. When are you going to have arbitrary slicing? You really oftentimes want to slice along a particular or parallel or perpendicular to a particular feature in the flow field, and so we've added capabilities to make that very easy. We'll show you that here as well. Also, we can do things like extractions. We can do that directly on the interface, which is good with a simple right-click. We also gave the ability to slice through surface zones as well. So if you just wanted to look at a set of slices on the surface, one can do that as well. So we've really focused on making the slicing capabilities much easier to use, faster, and a little more flexible. We also added something called pages. We'll go through this here in a minute. Idea of pages is simple. You can think of a layout as having a series of pages, almost like a presentation. So in this example I show, there's actually 3 plots that I might be interested in, and each one of those can be a separate page, or actually 4 plots in this case. And the idea is that as you're going through and analyzing your results, you may in fact want to have these kind of set views that are related to the data. And having those set views in your page stack allows you to go through and use it almost like PowerPoint, which is great. And I'll show you how that can be used, and it's very easy to use and very flexible. Last thing I'll talk about is macros. Macros have always been a mainstay of Tecplot technology. We have people who have written macros with tens of thousands of lines. Some people actually, one group in Germany, God bless them, but they did I think 50,000 lines in one particular macro, which is a testament to the macro language. It's pretty robust, but holy crow, that's a lot. I'm not sure. I would move to an add-on myself.
Yeah, I wouldn't necessarily do that, but that's fine.
But that's okay. And the last thing we'll talk about is how you can kind of quickly animate analysis or automate analysis. Okay, so I didn't want to spend too much time in PowerPoint. Let's go in and take a look at the actual technology. And I'm going to quickly make sure that I can see what you see, so that if nothing else, I won't be too far ahead of you. Okay, and someone asked, do I have to change the way I write the PLT files to leverage the subzone load on demand? You do. So we'll talk about that a bit. Okay, so it does look like everything's working. So very quick, here is the Tecplot 360 interface. A couple things to point out. That we've moved to a new GUI technology, which means that the sidebars and menu structure are effectively dockable. And so, for example, if you wanted to move these around, right now they're not customizable, but that is basically the direction we're going. So if you can envision then that I can actually set this up to be a little different interface. We also have this new welcome screen, which gets you a couple of things straight to the documentation. So if you choose to, if you need to get started quickly, you can go right into the scripting guide or quick reference guide, which I use somewhat frequently. You can also go to our online resources, including tutorials and videos, webinars, knowledge base. All this can be done from the main interface. You can also create a layout open a layout or load a data file, and I'll show you that we've made some changes there, and which is, I believe, a huge improvement over the way our current tool handles loading data. So let's actually leverage this by going ahead. We're going to go to open a layout, and you'll see we have a new, what I believe we call generic data loader, because it's changed a bit. In the past, when you loaded data in Tecplot, it came up with a list, and it said, okay, what data loader do you want to use? And Scott, that's not bad.
Right.
There's a lot of value there. But the disadvantage to that is that it's yet another menu that's coming up, and after a while, if you do it with some frequency, it can get kind of tedious.
Yeah.
So we've moved to something where all of the data loaders that you have available are registered in this main dialog, and therefore, if you choose to load in, say, a PLT file, and I put one out here on the desktop just for simplicity. One can actually just grab, here we go, top 5 data. Let's look at the low-speed example. You can just add it. You can either add it to the list, and you can have a number of data files that you load, or you can just load it directly. In this case, I'm only loading one, so you don't have to do that. But you can also load data files which are CGNS, Plot3D, inside file format, Excel, which we have an Excel add-in that I would recommend people using, Flow3D and the like. So it's a new way to interface with data, but I'll just grab this one, and I'll go ahead and hit open. Now, the data file I'm looking at is relatively small. It's just a simple UAV. And there's a couple of things that we've added that you couldn't have done before. Now, first of all, if I want to change the contour variable, which is on the surface, I can right-click on that surface and just say, yeah, let's look at pressure. So this is a very convenient way to quickly put pressure on the body. Of course, you could also look at, say, temperature, if you were interested in more of the temperature. And if you have these, we have our contour legend. If you right-click on a contour legend, you can actually change this to a filled background, a plain background, no box. I'll use filled. The other thing that you can do, you've always been able to do, if you double-click, it will bring you to that advanced feature dialog, which you can go through. So, can you load a layout file into another layout file? Yes, you can, and we'll talk about that here in a second. So let's say, for whatever reason, this was maybe what I was interested in. You can see temperature and pressure are both using the same color map. If we want to change that, we just go into our contour variable. Go in here, and we'll go into contour variable 1. And when we go to coloring, we can change that to, say, hot metal. And so you can have different contour color maps, and they can be one for each contour variable, as shown here. Now, if this was, maybe I'm interested in a little more detail on this particular simulation, this is where you might want to start looking at slicing. So we'll go ahead and we'll grab a quick slice, and this is a slice that's in the X direction. We've always been able to do X slices. If we go into the details here, you can see we have X, Y, Z, I, J, K. In this case, it's not structured, so that's not relevant. But we now have arbitrary slice. And what you can see now, if I kind of rotate this around a bit, is that we have an arbitrary slice interactor that you can see here, which I can actually now rotate freely in the domain and move it around. So you can, I'm going to actually just remove this as well. Okay, we'll go back here. All right, so we have this interactor, so we can actually move it, and we can actually move the interactor in space. Now, we're still making improvements to this, but you have a very easy way then to look at different normals, and you can align this with the data file or with the fluid domain to really analyze a particular plane of data. And this works both with subzone load on demand and regular Tecplot as well.
That's right. And when you use it with subzone load on demand, it will be selective about which subzones it loads. So it'll still have the full speed advantages and memory advantages.
So if this were a standard view, but in this case I'm looking at pressure, and oftentimes people say, well, gee, I really want to look at pressure, but I want to look at the temperature too. I'm going to copy this frame just using Control-C, and I'm going to go into Pages, and this page I'm just going to put in as pressure, and I'm going to add a new page, and we'll call this page temperature. So there's one of two things. I can actually go in here now and just paste. And what that does is it pastes the same view into this new page. And if I change the variable now, instead of flooding by pressure, I flood by temperature, which you can see it changed to temperature. Now, of course, I don't need the pressure on here. And the reason it's on there is because it's on the other wing. So I'll just hide this real quick. So we have the pressure now, or the temperature. So we have the pressure and the temperature in two different pages.
So Darrell, we have a question about can you make the plane transparent? I'm assuming they mean the slice plane.
Yeah.
And yeah, that's just a matter of going to the other page.
Sure. It's just going here and use translucency.
And turn on translucency. You can change the degree of translucency to make it more or less transparent.
Yeah. So you can see then we can look at the pressure, we can look at the temperature. Again, if you wanted to make it translucent, you certainly can. And if you want to go into temperature and make changes to it, like let's use divergent red-blue. It doesn't look like that's all that exciting. Let's do Doppler. Great. Okay, so you can do a number of different ways a number of different color maps. So very simple way. You can start to set up these layouts, and if I save a layout up here, if I save layout, what I can do now when I save that layout, and I'll put this on the desktop, that layout contains both pages. And we'll just call this pages. So it's a very easy way then to come back to it. And because we have the capability to overwrite the data as part of the layout load instruction, one can actually apply this multi-page layout to a new set of data and automatically create all these images. So, and they don't have to be this benign. I think that this particular example is not. What I've shown you is very simple, but if I actually go in and I'll open a layout that's a little more interesting that I think will help you understand kind of what's available. And I put this over here in local data, and I believe it's just the, let's see here. So there's a multi-frame there, but FSI, complete UAV, there we go. Okay. So here's an example, and we'll just replace, looks like the UAV data is out of there. Anyway, the idea is that you can actually go through and load that data as well. So I'm going to show you a couple other things. You'll get a chance. Can I incorporate GPUs to accelerate Tecplot data processing?
Well, the answer is yes and no. I mean, first of all, it's a graphics program, so it uses the GPUs for their original intent. Mm-hmm. And so certainly Tecplot will be dramatically accelerated if you have a faster GPU, mm-hmm. and you have a complicated image. Right? So it certainly benefits from the GPU there. We don't use general purpose GPU processing at this point, in part because there is the chance of conflicting with the actual graphics processing, and we want to make sure that we don't do that. But we are looking at that as a future option, if we can find a way to synchronize that effectively. Right.
So I want to talk a little bit more about some of the things you can do from a plotting perspective, and we'll actually stay perhaps in that pages layout. We can go back to it. You can see that it remembers kind of what you were working on. We'll just go back to the pressure here and go back to plot. And so perhaps actually we want to use macros as part of this. We probably don't need the additional pages just yet. So let's go ahead and we'll start by looking at, get rid of this real quick. We're going to talk about trying to do some of this stuff and actually leverage macros along the way. And someone asked about, I'm using 360 2010. I cannot see the colored graphics when I use, okay, well that may be, Josephine may want to take that question offline just because there's a lot more questions we'd have to ask to answer that one. So again, I'll go ahead and load the data file. In this case, we're going to grab that from the desktop. And I'm going to be looking at two different data files because I want to show you how you can leverage macros in the new quick macro panel as well. So we'll start with that same low-speed UAV. And okay, we're going to go ahead and just quickly do some processing. So I showed you that you can do an arbitrary slice, but I want to talk about what if you want to look at a CP plot on the wing or a pressure profile on the wing. And let's go ahead and show you how one can do that. So at first, you can see that I'm slicing in the X direction. I probably need to be in the Z direction. Okay. So here's the Z slice on the wing. And right now it's slicing through the volume zones, but I actually only want to slice through the surface zones. And I'd like to see not just the edge, but I want to see a mesh, and I'd like that mesh to be, say, pressure. Okay? So if I zoom in a bit, and also for simplicity, I know that a lot of people prefer to see the background of the frame in black. And you've always had this capability, but just for this example, I'm going to change this to black. And you can do that right here in the dialog, and voila, it's a black background. So hopefully you can see that a little better. There's there's the pressure on the wing. That's one slice. If I hold the shift button, I can grab a second slice. And you can see I can interact with these slices and show them. I'm actually showing a, we're not going to actually do that. As I said, this is an alpha version, so it still has some things that are kind of in work. So you'll have to bear with me when things don't work exactly the way they're intended. But we'll go ahead and go back to that. We'll look one more time here. Okay, so if we go back to that slice in the Z direction, and we're going to go into the details. I'm not going to show a plane while dragging. We don't really need to do that. We're going to go through those surface zones, and we're not going to show primary. We're going to look at start and end, and we'll look at, say, maybe 10 intermediate slices. And we'll look at, instead of the edge, we'll look at the mesh and make that, say, pressure. So,
can you make that line thicker?
Yeah, you can. So it looks like that particular is having an issue, so I'm not going to deal with that. Okay, well, the idea being that you can actually go through and slice that. Maybe I'll show you an actual much larger file. Maybe it's too small. For new technology, you need a much faster, more robust. Okay, so we'll go ahead and actually go, and we'll look at a similar example here. But this is actually subzone load on demand data, and what we're looking at is the slice of pressure on the wing. And I can, in fact, interact with this and change, see the start and end slice. Now, this particular data set, I believe, Scott, is about 190 million cells?
Roughly, yes. Just under 190 million cells.
Okay, so you can see that working with this data is actually very facile. So I can actually get rid of some of this stuff. And if I go ahead and do a shift click when I'm on the, I can extend my analysis. And you can see now I have CP curves that are basically, well, in this case, it's just pressure. Curves that are going along the wing. Now if I like these and I want to actually plot them in XY, I can right-click right there on the slice itself, and I can extract it. And so what it will allow me to do is do an extraction of the data for each one of these slices into a new zone. And so it's a very large file. It'll take a second to actually load in, but you can see it's done. Now if I go into zone styles, you'll see that I've got a bunch of slice zones. Now if I want to just select those slice zones, I can actually just type in slice, and you can see that it will grab all the slice zones very quickly. So this is another thing that we've added to make it easier to process data.
Right.
You can also set those into a new group, say slice group 3 or zone group 3, and so if you needed to, you could just grab the group. It does the same kind of thing. We'll select it. Things that we're working on right now are the ability to change. You can change anything via the zone styles dialog, but we're going to be changing some of the inline editing capability, which will make it a little easier to change style. So we're going to grab. Go ahead, Scott.
I was just going to say the significant change there is that you're actually using the right click in the zone style dialog. You don't have, before you used to have to go up to the top and click on a button at the top of the dialog. You don't have to do that anymore. It's very nice.
Yeah, and so if you were, if I was really only interested in, say, looking at the XY line plots here, I'm just going to quickly go up to data, and for simplicity, we'll go ahead and delete all these zones that we don't need just because we don't want to load them in by accident, and just stick to the slices. So I'll go ahead and delete those. Okay, so now we should just have a series of slices. If we go into XY line, you can see that here are those slices. I'll go into the mapping style. You can actually go in and change the mapping style to include kind of the dynamic text. So if you wanted this to be the independent variable name, you could do that as well. So you could say zone number in this case. So if we go zone number and add that in, and then we'll put in the zone or the dependent variable, or so we'll put that one in as well. So you can kind of change that, and you can see now it says zone 1 and Z because it's not particularly interested. But what we're going to show is that if I grab this, I'm going to go to the slice and I'll change the variable to be, say, velocity magnitude. And instead of X, because I think were we actually in the X? We'll see here if I close this for a second. Fit the curve. Okay, you can see that we weren't in the X direction. It doesn't look like. So you can actually change that to, say, Y. I think Y might be better. It's not. It doesn't matter too much. Y is constant. Let's do one last one. We'll do it in Z, and then it doesn't really matter for what I'm trying to show. So anyway, it's a bit noisy on the data. I wouldn't worry too much about it. Well, a couple of things to point out. If I wanted to change what's shown on screen to be a curve, so let's say that instead of looking at a simple line segment, I want to look at a polynomial fit of the data. Now you can see it's a really crappy fit, but that doesn't really matter for this example.
Fit all the data. Yeah.
You can actually show the details right on the plot. So here's the actual curve fit, and I'll make it smaller so you can see it. And we'll zoom in a tad so you can see that as well. So you can see that this is what the curve fit details for this particular curve fit, including the fact that we've got a R-squared value of 0.1, probably not publishable. You'll see. So again, the idea is that you can go in and change this on the fly to say, well, maybe this should be a linear fit. So you can go in and make this a linear fit as well. And you can see that it will update the curve, and you can see, hey, it's even worse. What do you expect? So that's just some of the things you can do. You can also change the line color directly. You can just say, oh yeah, I want that to be blue or green in this case. Same kind of thing. If you had multiple curves, you can deactivate them. So you can do a lot directly in the interface, which is kind of what we were going for. So hopefully I've kind of given you an idea of some of the things we have. Okay, we have someone who's looking at a DNS solution, but we'll get there in a second. So some of the usability information that I went through may change a little bit because we're still in flight. So there's some things that we're going to be adding along the way that I can't show you just because this is not feature complete.
So to just respond to this case, for very large data sets, what we've discovered is the majority of the time the cost is in the actual loading of the data. Right. That's the primary cost. And the secondary cost is doing your calculations on data you don't really need for the plot you're doing. And so in this case, we have solved both of those things by only loading the data we need and only doing the calculations on the data we need to do them on. Mm-hmm. So that has dramatically sped up Tecplot. As far as doing it in parallel, we are parallel. Let's be clear. If you have 25 core or 24 cores on your machine, mm-hmm. it uses all 24 cores. And so as we go to the more modern processors that have more cores, you're seeing a much faster processing time for those things that are not I/O limited. But again, it's so much of it is I/O limited with the traditional loading mechanisms in Tecplot and other post processors. That was what we have focused on first. And so I believe that if you try it with your DNS data, you'll find it is much faster now than it used to be.
Right. And actually, we're going to talk about speed for a moment. So a couple things. Right now, we have a way of profiling the loading of data. This is an internal tool we use that gives us an indication of how fast it is to load and process data. And I wanted to give you a sense of the difference in speed between Tecplot in its current form. And mind you, 360EX is about 2 times faster.
Yeah, if you deal with data that is not in the new format,
yeah,
it's still about 2 times faster than it used to be. Largely because we've done some effort to parallelize things that weren't parallelized before.
yeah.
So it's still a net benefit.
So in that context, I'm going to go ahead and open a layout, and this layout profile the opening of a layout for this transport airplane, and we're going to do it in the PLT format. So this is our current format. Now, Scott, when you presented this at the ASM last year, not this year's ASM, but last year, I think you said it took on the order of 140 seconds.
Yeah, yeah. So to load the full data set.
And make a slice. So we're going to go ahead and do that here right now. My guess is it's going to be less than that.
Yes. So this is actually the not with the subzone load on demand, right? This is
just an PLT file.
So it's still loading all the data, but we have, if you look at it as sort of a chain of events. The first event is loading the data, and then you go through processing, pre-processing, and then generation of the, I don't know if this is a slice or not, a slice, and then rendering it. So the largest cost is in that loading, and the next largest is in the pre-processing. And we've done a lot of work here to speed up the pre-processing. And so you will find that this is substantially faster than it used to be.
So it took about 51 seconds and used about 8.6 gigabytes of RAM. So compared to 140 seconds, that's more than
twice as fast. Again, this is traditional Tecplot files. You'll find similar effects with some of the other file types.
And so we're looking at about 185 million elements. So it's a relatively large data file. Okay, let's look at the subzone load-on-demand file, and we'll do the same profiling. So we're going to profile this layout. Again, this is not something that will be available in the release, but it's certainly something if you're interested in testing, you can join the beta program. And so we'll look at the SCL file now. This is the subzone load-on-demand technology. And I'll hit open. We're going to do the same thing. So remember, last time it took about 51 seconds. In this case, it took 3.8 seconds.
Right.
And used 700 megs of data, of RAM, pardon me. Which means I could load it on my Chromebook because it only has 2 gigs of RAM, and that'll definitely get you there.
We do test this every day by loading up to 2 billion cells on an 8 gigabyte workstation. So I mean it is pretty good. Question about remote data. We have an experimental client server using the subzone load-on-demand technology that is working, and we will. I don't know. It's not quite as far along as the other as the rest of the product, so I don't know that it'll be in the initial release, but it'll be available at some point, I'm sure, so that if you have remote data over a slow if you have remote data where you can't directly access the file, you would still be able to do your visualization on a local workstation.
Right. Yeah, and the challenge, we took an approach using what we call a subzone server, which if you have high bandwidth, it rocks. I mean, it's really fast. What we found, though, is if you have a slow pipeline between where the data is being processed and Tecplot, wherever you're running Tecplot locally, if it's a very slow pipe, it's just not great. And so we're still trying to work on how to make it better.
Yeah. So there's more work to do there, but we're confident we'll get that working very efficiently in the near future.
Okay. All right. So we've talked a little bit about subzone load-on-demand. Hopefully you get a sense of the speed improvements. And what was interesting is that, remember, when you put in a slice, you're only loading the subzones needed to make this slice. If I slice in a different area, it has to go out and pull those subzones in, but you can see that it's still very fast. We're still talking about a very large data file, and I've done an internal test, and I haven't really noticed. It's maybe a second or maybe a second versus 1.3 seconds, it's trivial. It's not really all that different. So, okay, so I wanted to talk about macros, and then we'll open it up to questions. Again, keep those questions coming. The client server, if you're interested in testing it and you have a fast pipeline, again, join the beta program. We'd love to have you on there. Let's go ahead and take a look at some of the macro capabilities. Now, one of the things I've done is you can see there's what we call the quick macro panel, which is actually now a sidebar. And there are 3 macros in there. These are 2 that just come with it and 1 that I created just before this presentation. And what the macro does in this case, if I want to slice on the wing, I can just select it and play. And what I'm going to show you is just how easy it is to go ahead and record and put a macro right here on screen. So, okay, what zoom? Oh, I think it's what is the zoom in like? Oh, MS Word. If you just use the middle click mouse button, you can zoom in and out. So, yeah. Okay, so let me go ahead and show you how to put a macro into the quick macro panel that you can use to automate workflow. Oh, okay, great. And yeah, someone asked about how do I write the format out. Basically, and we'll actually, let's go ahead and do that. We'll do this. We're going to do it all in a macro. Is the macro enabled?
Yes.
We'll give it a go. We'll see how this works.
I want to do it with this smaller file.
Yeah, we're going to do it with a small file. Okay. Let's go ahead and load a data file. We'll do the high-speed one since the low-speed one seems to be crashing. It could be the data. It's hard to know. And we'll go ahead and let's say that this is the file that you wanted to write out in SCPLT. What you would do is you go to Tools, and I'm going to export the current data file as the new format. And right now we're using the SCPLT. That's our internal name. It'll likely be SCL when it goes live in the final release. And we'll go to the desktop. We'll put it here, and I'll slap in a directory and call this SZ data. And what you can do is come in here and you can rename this, and I think this is high speed. Okay. And what it does then is it's going to take the data, and Scott, you want to talk about what's happening when it's
right,
doing
so it's
saving?
actually going through a process where it does a domain decomposition. Orthogonal, we use recursive orthogonal bisection, kind of quickly goes through and breaks it up into small pieces. There are separate subzones for the cells. This is finite element data, so you have cells or elements, and then you have your nodes, and so you have separate subzones for each of those, and it writes them out, and it writes out index files, and that's what it did. It took about, for this case, it took about 5 seconds to do this. Now this is an export from Tecplot. This is just one of the ways you can do it. The other is our TechIO library. And if you're interested in that, I would encourage you to come to the webinar we have in March. Yeah, I can't remember the exact date, but in March. And we'll talk about how to use that library to write it out, and in a lot of detail, more than we can do in the time we have available here.
So it's about 84 megs versus about 102 megs. If you open it up, you'll see that it has a tree file for each one of the variables, and then the data is contained in the SCPLT file. If we load that data, and let me show you quickly, layout. If I load that data in now, where I use the new data loader, and I'll grab the data file and open it, and basically what you get is it's blank. I mean, there's nothing really being shown at this point because we don't want to load any data unnecessarily. So if I go into the Zone Styles dialog and just say turn on these, I can turn on the shade, and it will actually just turn on the shade of the body. So you can see that it does put a box around the domain. This is the fluid domain. This goes out to the far field. So you have some sense of kind of the extent of the domain. And if I grab the slice here, and I'll put the slice right in the body here, and I think it was the Z direction here. And for good luck, we'll make that slice transparent, just because that was a request. So you can see through it. And I'll zoom in a bit. Okay. So this is kind of our standard view then of the data. And I'm going to write out a layout, but first before I do that I'm going to go save this as a style into a file. And again, we'll put it out there on the desktop in this data file under the SC, and we'll call this slice and Z. Okay. All right, so basically we have a style file. I'll go ahead and save a layout, and again, try to put it all in the right directory. Or actually, we'll go up a directory here and call this airplane SZL slice. Okay. We'll save that. So this is a very small file. You can see that now it's accessing. It's going to use just the subs on load on demand. Let's go ahead then and load the original file. Oh, don't worry about that. As I said, there might be something wrong with that particular file. I'm not too worried about it. Let's go ahead again, and we'll go to a new layout, and we're going to load the data file. And let's see, put that on the desktop, top 5.
So while you're doing that, I'm going to answer a couple of questions
Sure.
here. So does the new file structure use a single file for the entire data set? Yes, it does, except for the tree files. The tree files are in separate files for each variable, but all of the subzones are in one file. Can the arbitrary slice planes be defined by 3 points rather than a point and a normal?
That's the intent.
I believe so, yes.
Yeah, in fact, I'll save this real quick just because I wanted to do timing on it. But when you go in here under arbitrary, when you go to arbitrary, you can actually do the normal and then the origin. We will have the ability to do 3 points, but you can use a normal and an origin at this point. So.
Mm-hmm. So if you purchased SMS last August until August 14th, yes.
Yeah.
You'll get it.
You'll get it. Everyone who has 360 under SMS today will get 360EX free of charge. So.
Mm-hmm.
Anyway, okay, so that hopefully that answered your question. Let me go back to, again, a little more on the profiling. So we had, would you like to save? No. All right, so we have a couple of things I wanted to show you. Same kind of thing. I can do the tools here. Profile, open a layout, and the layout that we're going to do is the PLT, which when I open, you can see that it's like 0.6 seconds, super fast for it's a relatively small file. If I do the same thing for SCPLT, part of our plan is to do no harm. So we don't want, under any circumstances, even very small data, for there to be any hit with using subs on load on demand. So if we use the SC file, it's actually about twice as fast.
Yeah. So even for the small data, it's faster, and it uses less memory.
Yeah. So the key here is that because it's so slow or so fast, pardon me, if you use the SCPLT and you're using like Tecplot Chorus, you could process 100 files in 20 seconds, and that's pretty cool. Yeah. So that really makes speed. I mean, it's amazing if you try to run that many data files, and if you do it in parallel, heck, you could do. I have 32 gigs of RAM. I could run a lot of these.
Yeah.
So anyway, all right. I want to talk about macros real quick, and then we'll just open it up to questions because we're at 45. So. Let's say, for example, this was the layout, and actually for safety-ish reasons, I'm going to go to a new layout, and I'll load a data file, and we'll do high speed, and we'll kind of use this for the macro. So, okay, let's say that this is the data file, and I want a macro that's basically going to create a particular view or maybe do an extraction, which last time I think it was unhappy with the extraction, so I may not do that. But let's say you wanted to record a macro, and let's say the way that you record the macros now is by scripting. You go to record macro. I'll call this blah 2 because I'm not going to keep it around. Okay, so what I'm going to do quickly is I'm going to record the macro, and how I'm going to do that is I'm going to create an isosurface, And we'll change that to be, say, what's a good value, you think? Maybe -10.
Yeah, I'm not sure with this data.
I think that's the right one. Let's do a redraw real quick. Okay, yeah, it's not perfect, but let's go to maybe 0. Redraw. Nah, it's not that different.
Yeah, this is not a great data set, is it?
Yeah, it's not. But it doesn't really matter. I mean, the point, Scott, is not the data set. It's more about the macro. So let's say that this is effectively you want to take this macro or isosurface and extract it into a new zone and just show the isosurface here. Show selected only and redraw. It should be gray. It's pretty ugly. We don't worry about that. Turn off the edge. Turn on the contour. Make the contour say, I don't know, Z velocity. And redraw. So this is just, we wanted to make this image for whatever reason. We'll stop recording. Are you sure you want to? Yeah. So this isn't particularly interesting. You could have done a calculation. We just want to show effectively what you can do. So let me bring up that macro. So you can see here's the macro I've just recorded. And there's a bunch of things in here I may want to delete, but I'm not going to worry about that right now. We'll go ahead and copy this. And we're going to go into the directory where Tecplot 360 is installed, which is under Program Files, and I believe Tecplot 360EX Beta. And there's a file in here called tecplot.mcr, which is the macro file. And what we're going to do is we're going to paste in the macro I just recorded. And there's a couple of things we're going to do that we just want to change. We're going to put in here a macro name. And I believe, let's just go to the top of this macro, which is coming up here. Okay. So we'll call this, let's say, ISOME. Doesn't really matter. And you can see the macro actually has all the information about the contour variables that are used. Oh, and yeah, we're going to do the end macro function. And you can see the views that I changed. You can see that we set all the contour maps. We include the isosurface here, and there's an extraction event up in this area. What we're going to do is just put in this end macro function, and I'll hit File, Save. Okay, so we just saved the tecplot.mcr file. BLA2 isn't necessary. We're going to fire up Tecplot 360EX now, and you can see that there's a new variable called a new macro called ISOME, and I'm going to go ahead and load a data file. Let's see here. There it is. We'll do low speed. I think it doesn't make any difference since the data files are the same. And if I click now, I can play that macro, and voila, here is my extracted isosurface. And you can see that it's, in this case, translucent. It's not critical. So you can start to think of ways that you can automate the way that you interface with Tecplot. And because the Tecplot.mcr file is something that you can actually place in a working directory, the directory that you run Tecplot from, you could have a set of these that are kind of enterprise level that would have all the macros that you use with some frequency right here. And they can automate the analysis, including generating lots of pages, saving layouts, doing computational analysis, whatever you're interested in.
Yeah, it helps you customize your version of Tecplot to do just what you want to do. Specialized analysis.
Absolutely. So I've kind of highlighted a number of the new capabilities in the tool. As I said, this is still a work in progress. We're doing a fair amount of change. But there's lots of different things that, you know, if you didn't know that we had changed, like the way that probe works, now you have a whole different interface, which is more like a table, whereas before you had to do page up, page down. In the zone styles dialog, there's a number of things that have been changed to make it easier, including the groups. You also have color coding, so you know that this is relative to the mesh itself. The zone information is always in blue, and information about pattern or line thickness is always in orange. And we're kind of going to update these colors to be a little, maybe a little sharper, but the idea won't change very much. We have this ability now to very quickly select lots of zones and change them. So that's kind of a new capability that we've added. We have the right click as well as...
The organizer has ended the session, and this